Hi, everyone. My name is Vikas Bhatia, and I'm the head of product for Azure Confidential Computing. I'm super excited to talk to you about what's new in this evolving field of Azure Confidential Computing. So let's get started. There are three things that I'm going to cover today. If you're not familiar with confidential computing, I'll give you a bit of a background that might be useful for you to understand what this is. Next, this space is rapidly evolving. So we will talk to you about the new innovations and new releases that we've got coming in this space. And last but not least, along the way, we'll tell you about the use cases that we see customers using this for, and then a specific section on a particular industry verticals. So let's get into the background. What is confidential computing? But before we get there, I think it's important to acknowledge the era of flux and transformation that we see in the space of security today. Attackers are getting smarter, so many tools. The amount of noise that we see in the space is just so much right now. It's hard to separate the signals from the noise. In addition, it is important to call out that Azure cloud security today is already best in class. We have more than 650,000 customers leveraging Azure cloud today. Microsoft itself employs more than 8,500 security experts. In 2020 alone, we saw 9 billion malware threats that were blocked with Microsoft 365 Defender. And we process over 24 trillion signals every 24 hours. All that goes into saying that Azure cloud today is already secure, already best in class, and customers are running billions of dollars on the Azure cloud today. But with security, we can always do better. And what we see today is our customers are looking to trust as little as possible. Our customers are getting sophisticated. And what's driving this? What's driving this is they want full control over the data lifecycle. This is being driven by privacy, evolving regulations and compliance that we see happening in the European Union around the world. Trust. We need to make sure when customers give their data to us, we are storing that data, taking care of the data, such that we don't lose that trust. And there are new scenarios that were really hard to do before, such as untrusted collaboration, that now become possible and really easy with confidential computing. So, what is the state of data protection lifecycle today? Today, the technology with existing encryption technologies, you can now protect data at rest and data in transit. You can take my laptop, there's nothing you're going to get out of it because I have BitLocker on. Similarly, in the cloud, when my data stays at rest, it is encrypted with a key I own. Similarly, data in transit. We don't really do HTTP anymore. We do HTTPS, we do TLS. Similarly, when we transport data in the cloud, we encrypt that data when it is going over the wire. But when customers' cloud is running, it's running in a larger context. There are administrators that the customers who have access to their data. There's a guest operating system that the customers run on. And their cloud runs in the context of a larger cloud where there's a hypervisor or a host operating system that's managing the instances. There's physical access by data center administrators. Of course, we do our very best. And as I already said, Azure cloud security is already strong. But the point here is that there is a larger context that the cloud runs on, and customers are becoming sophisticated. They are asking us to increase the capabilities of security in the cloud. And this is where we're excited about what confidential computing brings. Confidential computing is that missing third leg of the data protection lifecycle. Confidential computing helps protect data in use when it is in memory while it is being computed on. The other important thing with confidential computing is with confidential computing, data is in customer's control from the time it's created to the time it's stored, to the time it's transported, and when it is in use, and finally when it is destroyed. And you get protection from malicious insiders, hackers, and new scenarios such as multi-party confidentiality. And in Azure, confidential computing means an independent hardware root of trust, verifiable attestation, and memory encryption capabilities. So what is confidential computing? We have been working with the Confidential Computing Consortium. We were one of the co-founders back in September 2019, which has many of the industry leaders as part of it. And the way they define confidential computing is protection of data in use by performing computation in a hardware-based trusted execution environment. And what you get as a result of it is verifiable assurance for data and code integrity and data confidentiality. So now let's switch gears and talk about confidential computing in Azure. How do we think about it? And when we think about confidential computing in Azure, we have unique capabilities to help you achieve the highest levels of data privacy. We believe in an independent hardware root of trust that's rooted down to AMD, Intel, or NVIDIA. We have attestation capabilities where you can now verify that your environment is exactly the way you expect it to be. The attestation service itself runs in a confidential environment. And keys, we all know how important keys are. We took Azure Key Vault and we created Azure Managed HSM, which itself runs in a confidential environment. And it gives you secure key release capabilities that ensures that your keys are only in the clear when they are inside the enclave and encrypted outside. In addition, our strategy is to make our first party services confidential. Azure provides a slew of confidential PaaS SaaS services that you can now leverage on Azure. So this is what confidential computing in Azure looks like. We think about it as virtual machine containers and services that we are making confidential. So right at the bottom, we see these different virtual machine sizes, such as DCA or ECA virtual machines on AMD, DCS V2, DCS V3 virtual machines on Intel SGX, and we have NVIDIA virtual machines, which are in limited preview. Higher up on the stack, as the world is moving rapidly towards cloud native and containerization, we provide options to protect your containers, whether they are in an SGX environment, in an AMD environment with confidential VM worker nodes that can be managed with AKS, and also serverless containers with confidential ACI. Higher up the stack, I already covered the managed HSM service and the attestation service. We have a new service that we announced as generally available earlier this year with Azure Confidential Ledger that I'm going to talk about more later, which gives you tamper-proof audit logs. And there are new capabilities that I'm also going to talk about where you can run your SQL IaaS installation on a confidential virtual machine. We've already had SQL Always Encrypted with secure enclaves that's generally available for some time. And I'm excited to announce a public preview of Azure Virtual Desktop on confidential virtual machine and a new limited preview service, invite-only service with Azure Managed CCF. Before we dive deep into it, I think it's important to talk about confidential computing as it is on a spectrum. There is never a one-size-fits-all. On the right, you see these enclave-aware applications that you can build with Open Enclave SDK or Confidential Consortium Framework or many of the other SDKs that are available publicly. What you get is exact line of code control of what is running inside that enclave. And then you can use purpose-built services like the ones I mentioned earlier. Moving a little bit left, you can use containers that are confidential, but now in this case, you're lifting and shifting your containers in a confidential environment. The advantage of this is you don't have to change a single line of code. You are taking more code in your trusted computing base, which is totally fine because you know what is you're running. Moving further left, you have confidential virtual machines and AKS node pools that we are making available through confidential GPUs and SQL Server and AVD, Azure Virtual Desktop confidential virtual machines. Let's cover them a little bit. So in Azure, we have different kinds of trusted execution environments on CPUs. Azure is unique because we offer a breadth of capabilities here. On the left, we have AMD confidential virtual machines, which basically give you the ability to lift and shift into a confidential environment. So you get two levels of encryption. You can encrypt the memory when it's in RAM, and you can also pre-encrypt your operating system disk. And you're isolated from the hypervisor and the host components that sit below it. The operating system can be pre-encrypted, as I mentioned, and you have multiple key management choices. You can have a customer managed key, a system managed key, leveraging a managed HSM or AKV environments. On the right, this is Intel SGX software guard extensions, where you can now get VMs with app enclaves. So here you break your application up, you partition your app into an untrusted and trusted region, and the sensitive code goes into that trusted environment. So here you have encryption of memory, VM memory, and RAM, plus app-specific EPC memory, which stands for Enclave Protected Cache Memory. We have capabilities such as TMEMK that encrypt the entire VM memory. And in addition, you get EPC memory where you can run your trusted code. So we also have a rich ISV and open source ecosystem that can help you deploy your existing containers without any code changes. We are seeing a ton of customers deploy their Python containers, for example, for AI ML workloads that don't really require any code changes because they can wrap it with an SGX wrapper so that it runs inside the enclave. Of course, there may be APIs you may need to change, but many times code doesn't need to be changed. So let's double click a little bit into these app enclaves with Intel SGX. Azure is unique. We were the first cloud provider to provide a virtualized environment for Intel SGX, which gives you the ability to achieve the highest levels of data privacy with control over every single line of code if you so desire. And these are available with DCS v2 and DCS v3 applications, leveraging Intel SGX and TME MK memory encryption. In the latest generation DCS v3 virtual machines, leveraging third generation Intel Xeon scalable confidential processors, we have increased the EPC memory 1500x to 256 gigabytes compared to previous generations. We're already seeing a ton of customers leveraging these capabilities. Here are two example customers that we've been working with that are leveraging these Intel SGX TEs on DCS v2, DCS v3 virtual machines. The first is Signal Messenger. You may know them. They're one of the top messenger services. They leverage Intel SGX to keep the contacts secure. They are leveraging these capabilities for faster, higher level security that is available on the public cloud all around the world. On the right, we see Fireblocks. Fireblocks is a great innovative company that powers crypto transfers. And they're using these SGX enclaves to secure the keys for the digital asset custody and transactions. And what they get is privacy protection, encryption of data in use, all built on third generation Intel Xeon scalable confidential processors. Let's switch gears now into AMD and specifically SEV-SNP. SEV-SNP, the SNP element is important because it gives you integrity protection. So with AMD SEV-SNP, you can make your applications confidential without any code changes. These are now available through DCA SV5 and ECA SV5 VM series. These are generally available now. You can go to the portal and start using them right now. You can get memory encryption with CPU protected keys. You can leverage our full OS disk encryption with keys that is rooted down to the VTPM. We also have guest attestation capabilities that I'm going to talk about in a minute. And you can leverage these on third generation AMD EPYC Milan processors with SEV-SNP technology. Here are a couple of customers that we see leveraging these SEV-SNP environment on ECA v5 or DCA v5 virtual machines. Three of them being F5, HashiCorp, and BMW Group. They are leveraging these technologies to get defense in depth. They get more sensitive data protected with SEV-SNP technology, and they get additional security controls with disk encryption. I talked about guest attestation before. Guest attestation is a key capability that we are now making generally available, the one you see on the right, where you can now use these confidential virtual machines on a hardware-based trusted execution environment. You get security features such as isolation, integrity, secured boot, and you can now deploy before you know that your environment is a desired good state. The one on the left that is now being generally available, we announced this in public preview early this year, with confidential VM node pools on AKS. You can get data and use encryption for your AKS agent node pools. This gives you seamless deployments for your Linux containers. You get full AKS parity, and you can also use these guest attestation capabilities. Guest attestation is such a key element. I feel we should get into a demo. So let's watch a demo.
Guest attestation feature helps in verifying that a confidential VM runs on a hardware-based trusted execution environment with security features turned on. Here are some customer scenarios. Let's say you have a sensitive HR workload in Azure, a recent lift and shift workload from your on-premise environment. You can use guest attestation capability to ensure that the confidential VM is running on AMD SEV-SNP hardware, T, and secure boot is on. Only when these artifacts are verified, the HR workload is launched. In this scenario, two systems, a code signing service and a crypto node, interact with each other, and the crypto node, which is a relying party, wants to ensure that the code signing service operates in a confidential environment and the transactions with it can be trusted. Upon receiving code, the code signing service signs the code and sends a response that includes the signed payload and JOT obtained from the guest attestation library. The crypto node extracts jar artifacts to verify that the code signing service can be trusted and the signing payload is not tampered, and then it proceeds with payload processing. This is a demo of guest attestation. Here is a portal where I have pre-created a confidential VM, which I'll access remotely from a terminal. I can run a command to view the attestation report and see that it returns success. This remotely verifies with Microsoft Azure Attestation that it's running on an AMD machine with SEV-SNP memory encryption, and the entire firmware and software stack matches the expectations of the trusted computing base. In the decoded view of the JSON, you can see the TPM, host data, and launch measurement of the attestation report. This attestation token can be used within a helper utility scripted at runtime to verify the environment before an app unlocks and processes data, keeping customers in control at all times.
So we covered CPU trusted execution environments. Let's talk a little bit about confidential GPU virtual machines. These are now in limited preview, and our vision here is to ensure that your data and code remain confidential in a GPU environment along with a CPU environment. These are great to protect confidentiality integrity of AI workloads in use. These are great for secure ML workloads, large data AI workloads, marketing, advertising work, elements that require you to deal with a ton of data. We've been working with NVIDIA, and we have these available in limited preview on A100 Tensor Core GPUs. Next, I'm super excited to talk a little bit more about our confidential serverless ACI containers. We announced them in limited preview earlier this year, and these will be in public preview really soon. You can now make your containers confidential without changing any source code and deploy them in a serverless environment with confidential ACI or Azure Container Instances. You get full attestation with platform integrator tools, and these are really ideal for confidential AI workloads and short-lived burstable workloads. What you get is a dedicated hypervisor and hardware-derived in-memory encryption per container group. All of this without having to change the code for your containers. Next, we're excited to talk about the confidential VM option for SQL Server on Azure VMs. So with this capability, you can have a full SQL Server installation on a confidential VM. VMs can now get additional protection with data in use. You can add defense in depth to your existing SQL Server security features. And in addition, you get remote attestation at boot. Attestation, again, is such a key component here. And these are super ideal for lift and shift workloads. So previously, you were installing SQL Server on a VM. Now you can install it on a confidential VM. And again, a new announcement, which is we're announcing a public preview of Azure Virtual Desktops on confidential VMs, which gives you a complete Windows 11 desktop and application experience running in a confidential environment. So you now get secure remote access with Windows Hello, and even get Windows 11 multi-session capabilities. Leveraging this capability, you can also auto-scale confidential VMs as the demand changes. So you get the cloud benefits with a virtualized environment running in a confidential environment. I'm also excited to announce a new limited preview for Azure Managed Confidential Consortium Framework. This gives you speed to market in developing stateful services, reducing dependency on compute nodes and specialized labor when you compare it with traditional digital ledger technologies or DLTs. Moreover, the approach allows for deployment of CCF-aware or confidential consortium framework-aware applications over a verifiable confidential network. The consortium-style governance allows programmable confidentiality between multiple parties, all running in a confidential compute infrastructure. I mentioned earlier that this is leveraging the confidential computing framework. This confidential computing framework has been something that we have had available for a while now. This builds stateful services on a privacy-enhanced decentralized trust framework, where you can combine PEEs and flexible decentralized governance to create these high-performance, multi-party confidential applications backed by an immutable, verifiable history. Now, best of all, the ability here is transaction activity can be governed through this immutable capability of a verifiable history log. So now let's compare the three different offerings. On the left is where you're creating a environment with a non-managed environment without the CCF framework. And the dotted lines are what you are responsible for. On the left, you have a permissioned digital ledger technology where you have to build your business logic, build the application logic, set up that permissioned DLT system across these multiple parties that you're working with, and you're running it on general purpose computing. In the middle, with our capabilities of the open source CCF framework, you still create the business logic, but you're standing up and managing the CCF framework yourself. We've already had a bunch of customers doing it, but now what we see the advantage is this is running on a confidential computing frame environment. And because we've seen a bunch of customers leveraging CCF framework, we are now increasing that and making that more usable with a managed environment with a managed CCF framework. So here, your responsibility shrinks to creating the app and ensuring that you have a business logic, and the managed environment will help you quickly deploy highly available CCF network to build your own stateful service, allow you to add consortium framework, upgrade your CCF applications as you go, and also monitor the applications debugging logs that you need. I want to talk about a great new use case that we've been working with Carbon Asset Solutions. So they want to take on climate change through a program to encourage farmers to practice soil management practices that sequester carbon dioxide emissions. They leverage Microsoft Azure Confidential Computing and Azure Confidential Ledger technologies to help make soil carbon data and carbon credits private and tamper resistant. These technologies work seamlessly within the Azure environment, leveraging the .NET framework, leveraging the Azure DevOps toolset. And as I mentioned, they leverage Azure Confidential Ledger. The Azure Confidential Ledger was built using the CCF framework that I talked about before. So as you can see, we are seeing all of these use cases arrive, and we see customers doing really innovative things, such as what Carbon Asset Solution is doing for climate change. So let's double click a little bit into these use cases that we see by industry. First, we've seen a ton of traction, with regulated industries. We see a bunch of use cases on retail and advertising, such as clean rooms and multi-party AI/ML, targeted offers. Financial services have been an early adopter with scenarios such as anti-money laundering. We see a bunch of customers leveraging confidential computing for Web3 scenarios, such as digital currencies or decentralized finance. On the healthcare side, we've worked with a bunch of customers on disease diagnostics, to help multiple health providers merge their data in a confidential environment where the only thing that comes out is the report, and the data and the algorithm can be destroyed after the work is done. So we see all these innovative use cases happening right now. One specific use case that I would love to talk to you about is what we announced recently with the Microsoft Cloud for Sovereignty. Here, we are leveraging our expertise, governance and transparency, and giving you sovereign controls where you get policies to protect data in rest and in transit, along with data and use processing with confidential computing, and give you data residency capabilities. So here's an example of a sovereign workload spectrum. And again, this is just an example, but this is to show you how you may get your data and deploy them in these different environments. So if you have ordinary data, Azure Cloud is already super secure. You can run your critical data on it. What we get with sovereign workloads is you can get data residency with in-cloud region support. And for critical data, you can leverage confidential computing for workloads which need data sovereignty. And for strategic data, you can manage them with Azure Arc in your own data centers. We've been working with a bunch of public sector customers on this, and we're excited to see the kinds of use cases and workloads that they're bringing in this confidential environment. One such example is Proximus. They are keeping the customer trust and meeting the EU regulations with confidential computing. They are one of the biggest telcos out of Belgium, and we are super excited with the partnership with them. So what is it that we mean when we say a confidential cloud? The first is that the data is fully in control of the customer, whether it's at rest, whether it's at transit, or now with confidential computing when it's at use. And the cloud provider, the cloud platform provider, which in this case is Azure, it's outside your trusted computing base. The code that you're running in the cloud is protected and verified, leveraging remote attestation by you. And leveraging capabilities like confidential ledger, the activity history is immutable and auditable. And the confidential computing industry itself is rapidly projected to grow. This is a research that was done by Everest Group, a third party research company, that expected to grow 26x over the next 5 years, largely driven by privacy, compliance, and regulations, evolving landscape around us, new use cases like multi party computing, and the global applicability of this capability that they expect this market to be over 50 billion over the next 5 years. So, this is what I want to leave you with. Confidential computing is the future of computing. Here are a bunch of links that we encourage you to try out. We've got a bunch of good documentation, a bunch of success stories that you can look at. With that, I want to thank you for the time. I hope this was informative. Thank you.